us quickly brush up our concepts of parallel sailing, which I'm sure all of us are aware of.
Beta, is the audio video both working fine?
Yes, sir.
Okay, beta, great.
Now, when a vessel sails along a given parallel of latitude, that means along an easterly course, that is 090 degrees true, or a westerly course, that is 270 degrees true, the sailing is referred to as parallel sailing. We already know why it's called parallel sailing, because you're moving along a given parallel of latitude. Now, departure is the east-west distance between two places expressed in nautical miles. So please note, it has to be expressed in nautical miles, and it needs to be the east-west distance between the two places or points. Now we have a parallel sailing formula, which gives us a relationship between d long and departure, and we all know it. Cosine of latitude is equal to departure upon d long. Obviously, this cos lat cosine is a trigonometric ratio. So obviously the units of departure and d long will be same.
Clear up to here, beta?
Yes, sir.
Very good.
So here we have the world map on the screen. Let us say we need to depart Tokyo in Japan, which comes up on the screen marked as point A, with its coordinates also showing up. And we need to reach Seattle in United States. It also comes up on the map marked as point B, with coordinates of the Seattle also showing up on the screen. Obviously, our preferred route shall be Great Circle sailing to save on time. And in this case, you can see it shall be across the 180th meridian, across Pacific on an easterly track. Now let us quickly draw a PAB triangle between Tokyo and Seattle on the globe. Here we have point A, here we have point B, Seattle in United States. We join them with a shorter arc of Great Circle. So this is from A to B, the arc Great Circle track between A and B. This is the vertex of this Great Circle track. So we have the GC track from A to B as well as the vertex of this track. Now we can see in this case the GC track is easterly because the D long from A to B is easterly. Let's now draw the meridians of A and B. So the two meridians come up on the diagram, and what we get is a PAB spherical triangle, which we all know that if enough information is available, can be solved.
So what you see now, beta, is the actual PAB triangle on the surface of Earth. So this is the actual PAB triangle.
Now this white track out here is the rhumb line track between the two locations, and we can see that the rhumb line distance obviously is greater than the GC track, and therefore the preferred track shall be the GC track from A to B. For the sake of clarity, let us see how these two tracks, that is the GC track and the rhumb line track, would appear on a Mercator chart. Now, this is how the tracks would appear on a Mercator chart. On Mercator chart, the GC track would be a curved track, and a rhumb line track would be a straight line track. We all know that on Mercator charts, because the meridians are parallel straight lines, therefore the rhumb line tracks are straight lines. Now here it may appear that GC track is a longer distance, but that is not so. It is the GC distance along the GC track which shall be the shortest distance. How would these two tracks look on a mnemonic chart? Let's look at that. Now here we have how it would look on a mnemonic chart. On a mnemonic chart, it's polar mnemonic. GC track would be a straight line, and rhumb line track would be a curved track. So hope these two comparisons also bring in clarity about how these tracks appear on different projections.
This is just for your understanding, beta. Not that we require them in our solution. We will not need them in the solution. Just for your understanding how the tracks look on different projections.
Now, having appreciated as to how these tracks appear on different projections, we come to the most important part of our discussion. And for that, we go back to the PAB spherical triangle constructed between Tokyo and Seattle a while back. Now, on this globe, we can see this PAB triangle, with this one being the GC track between A and B. On examining this track, what do we see in this part of the track? We see that some part of the track appears to be passing over land or maybe non-navigable waters. Now, this could be one reason, or there can be other contributory factors also, which may force a vessel to decide on the highest latitude that it would not like to cross during her voyage. The highest latitude that the vessel would like to reach and not cross is referred to as limiting latitude. Let us say, factoring in all the requirements, in our case, let us say we decide to limit the latitude to 50 degrees north. Here comes the parallel of latitude of 50 degrees north, and now obviously it's very clear that the vessel cannot go from A to B along the GC track because some part of it is crossing the limiting latitude.
Is it clear up to here, beta? Any doubts coming in?
No, sir.
No, sir.
Very good, beta. Great.
In such cases, to strike a balance between the shortest possible distance and also meeting the requirements of not crossing the limiting latitude, the vessel may use combination of sailing. In this case, combination of great circle sailing and parallel sailing. What does the vessel do? Vessel figures out a GC track whose features include A, it passes through departure position A. 2, it has its vertex on the limiting latitude. So here is the GC track passing through A with its vertex being here on the limiting latitude. V1 represents the vertex of this blue GC track AV1. Now, this is a GC track, obviously. This is the meridian of V1, the vertex. We all know that this meridian will make an angle of 90 degrees at V1. So what do we get? We get this shaded right-angled spherical triangle. PV1A is a right-angled spherical triangle.
Now, this is the important aspect of composite sailing, beta. We choose our initial track in such a way that it passes from our initial position, that is alpha, and this track has its vertex on the limiting latitude, which is V1. So this is the basic fundamental of composite sailing. Any doubts up to here, beta?
So whichever limiting latitude we are selecting, that will automatically become 90-degree east-west. Is it like that?
Yes, that's correct, beta. Because our track alpha vector 1 is such that it has its vertex on the limiting latitude, so vector 1 angle would automatically become 90 degrees.
Okay, sir.
Okay, great.
Likewise, we figure out a GC track passing through B, again having its vertex in the limiting latitude. So you can see this one. Here is the vertex of the GC track marked with V2. So what is BV2? It's an arc of great circle passing through B, having its vertex in the limiting latitude. Here is the meridian of V2, and obviously this will also make an angle of 90 degrees with the GC track. We get another right angled spherical triangle PV2B shaded out here. Now we get two right angled spherical triangles PV1A and PV2B.
So you see beta, the exact same thing is done at the destination position also. The leg of the passage Bravo Victor 2 is such a great circle track which passes from our final position, our destination position Bravo, and it has its vertex on the limiting latitude, which is vertex Victor 2. So Papa Bravo Victor 2 is again a right angled spherical triangle. So this is the third leg of our passage.
So we can use Papa Victor 1 Bravo.
Uh, cannot do like that beta, because if you make a great circle track between Victor 1 and Bravo, it will cross the limiting latitude. It will go above 50 degrees latitude.
Okay.
Vessel moves along this arc of great circle, so this becomes GC track. Vessel also moves from V2 to B, that becomes a GC track. And from V1 to V2, vessel moves along this parallel of latitude so that it does not get crossed, and that becomes a parallel sailing track. So V1 to V2 is parallel sailing track. So the vessel's total track from A to B shall have three segments. A to V1, great circle, V1 to V2, parallel sailing, and V2 to B as great circle. Now let's look at, analyze each of these tracks out here. You can see on the screen. Let's analyze track AV1. How do we calculate all these things now? Now to calculate track AV1 distance and course and other things. Now what is the type of the track AV1? Obviously GC has already explained. We know this side. Why? Because we know the limiting latitude, that is the latitude of V1. We also know this side PA. Why? Because we know the latitude of point A. Now with right angle triangle, two parts known, we can use Napier's rule and we can solve for this angle. It will help us in getting the longitude of V1. We can solve for this arc AV1, that will give us the GC distance between AV1. And in this case, the distance works out to be so much. And we also solve for this angle, which will help us in getting us the initial course when the vessel sets sailing along the GC track AV1 from A. Exactly the same way, we can solve for triangle PV2B for track V2B. We know it's a GC track. We know this because this is the colet of the vertex. This is the colet of point B, and we can solve for now this angle, which shall help us in getting the coordinates of the vertex. We can solve for this V2B arc, which will help us in giving the GC distance on the third leg. And we can also calculate this angle, which shall help us in getting us the final course of the vessel. Now, we also know that this angle at P, this angle at P is the D long between A and B. Now, knowing this full angle and also knowing these two small angles calculated while solving the right angle triangle, we can get this angle, which is the D long between V1 and V2. Now, knowing the D long between V1 and V2 and knowing the latitude along which parallel sailing is being executed, we can calculate the distance V1, V2 by parallel sailing formula. So we have all the three tracks then solved out here, and this sort of sailing, wherein we use combination of more than one sailing, is called as composite sailing. And in this case, the composite sailing involves great circle sailing plus the parallel sailing.
Okay, beta. So have a good look up to here and let me know the doubts coming in.
So can you explain track V1, V2 only? V1, V2.
Okay.
Yes, sir. Track V1, V2.
Okay, beta, I'll tell you. Now V1, V2 is a parallel sailing track, beta. We just now saw that the formula with which we can calculate the parallel sailing distance is departure is equal to d long into cos of m lat. Right, beta?
Yes, sir.
Okay. So basically we want to calculate the departure between V1 and V2. So for that we require the d long. d long between vector 1 and vector 2. The latitude is already known. V1 and V2 are at 50 degree north latitude. So how do we get the d long between V1 and V2? Basically, we want to find the angle vector 1 papa vector 2. So what we do in this beta, we have the full angle alpha papa bravo. It is the d long between A and B. We know the longitudes of A and B, so we can calculate angle alpha papa bravo, right?
Okay, understood, sir.
And we
then
have
minus.
also calculated the smaller angles alpha papa vector 1, which is calculated using Napier's rule, and bravo papa vector 2, which is again calculated using Napier's rule. Both these smaller angles are subtracted, and this middle angle vector 1 papa vector 2 is found out. This gives the d long, and that is used to calculate v1 v2.
Okay, sir.
Okay, sir.
Okay, I will show you an example also where this is practically done. We will see that.
Excuse me, sir.
Go ahead, beta.
So this composite sailing track will always have a combination of two GC and one drumline tracks.
Not always, beta. There is a possibility that there may be only two tracks, alpha vector 1 and vector 1 vector 2. That happens when your destination port is exactly on the limiting latitude.
That means 50 degree north. V2 is on 50 degree
Exactly.
north. Then
Exactly. If your destination position was at 50 degree north itself, the third leg, vector 2 to Bravo, will not be required in those cases.
okay, sir. Cool.
Okay. Great. Let's see an example, beta.
Let's quickly summarize the key points of our discussion. Composite sailing comprises of combination of great circle sailing and parallel sailing. The highest latitude not to be exceeded by vessel during a voyage is called as limiting latitude. Reasons that could necessitate limiting latitude during a voyage could include, amongst others, great circle track passing over non-navigable waters, weather routing advised to avoid high latitudes, or ice conditions in the high latitudes. So if there are reasons to limit the latitude, then to strike a balance between shortest distance and a safe track, we could use this, what we have called as the composite sailing. Having discussed the concept of composite sailing, now we list down certain steps which shall facilitate in making of the diagram and solving the problems related to composite sailing. We first plot the departure and arrival position in correct relative orientation to each other, and the same care needs to be exercised what we learned when we learned to make the PAB triangle. Here is position A and here is position B. Then we identify the appropriate pole. The pole of the hemisphere in which the limiting latitude lies would.
Go ahead, beta. Any doubts up to here?
सर ये वीडियो
No, sir.
आप फ्यूचर में भेजोगे सर?
बेटा this will not be available. अगर कोई doubts आते हैं, just tell me, I will explain it again.
Okay, sir.
Okay.
With the appropriate pole. Then we draw the meridians of A and B. Now, if it was a GC problem, we would have drawn the GC track from A to B, but in this case, we will mark off the limiting latitude. And the red one in the diagram is now the limiting latitude. Next is we draw a GC track passing through A with its vertex in the limiting latitude, the way the green track has been drawn. And here is the vertex of this track, V1. Likewise, we draw a track between B and limiting latitude with the vertex in the limiting latitude, and V2 is the vertex of that track. Now this entire track from A to B has three stretches. One is A to V1, which is GC track. V2 to D, again a GC track. And V1 to V2, rump line sailing along the limiting latitude. Now we can draw the meridians of V1 and V2. Angle at V1 would be 90, and likewise angle at V2 would also be 90. Now we get two right angled spherical triangles. One is PV1A, other is PV2B, which we can solve using our Napier's rules. Now let us first mark the parts which we can figure out from the information that may be contained in the question. Now this is the colet of A. I'm sure all of us can calculate knowing the latitude of A. Likewise, this would be the colet of B. Then this will be the colet of V1. Now, since you know that V1 lies in the limiting latitude, so you know the latitude of V1 and V2, and hence you can calculate PV1 and also PV. The longitude of A and longitude of B shall give us this angle, which is the D long between A and B. So this angle is also obtainable. Now, having identified the parts which we may know, we can use Napier's rule to calculate which all parts. Let us mark them also. We can calculate this angle. This will be the D long between A and V1. So knowing the longitude of A, we can use this D long and get the longitude of V1, whose latitude is already known to us. Then we can solve for this angle at A, and this angle shall help us in getting the initial course of this GC track AV1. We can also solve it for this side AV1, and this shall be the GC distance between AV1. Likewise, we can solve triangle PV2B. This angle will be the D long between V2 and B. Knowing the longitude of B, we can get the longitude of V2, whose latitude is already known to us. We can solve for angle B, which will help us in figuring out the final course when the vessel reaches B along the GC track V2 to B. We can also calculate side V2B, which will be the GC distance on this last leg of the voyage. Now, having known this full angle, having known these two angles, now this angle can also be obtained. This will be D long between V1 and V2. Now, when we know the D long between V1 and V2, and we also know the latitude, we can calculate by parallel sailing formula the distance along this track. That will be the rump line distance, and this way we'll be able to get the total distance, which will be sum total of all the three legs. We shall be able to get the initial course, and we shall be able to get the final course as well.
So a recap of what we did in the previous diagram. Now this diagram, if you see, is much simpler and easier to make. So this is what we make in our answer sheet for solving the questions. Very simple diagram, and we solve it in this particular way. So let us now see the the solution of the question step by step.
We understood the concept of composite sailing. Let us now solve a question. Calculate the initial course, final course, and distance along the composite track from 37 degrees 40 minutes north, 141 degrees east, to 36 degrees 48 minutes north, 122 degrees 40 minutes west, with a limiting latitude of 42 degrees north. Now, the first and foremost thing is to make appropriate diagram. So we mark off departure position A. Now, in relation to this, we mark off arrival position B, which shall be to the east of A and slightly to south. It comes on the screen. Now we mark off the appropriate pole, as the limiting latitude is north. So the appropriate pole is north, up on the screen. Now we draw the meridians of A and B. They also show up on the screen. Now, if we had to take a great circle track from A to B, we would have drawn the arc of great circle passing through A and B. But in this case, we have a limiting latitude of 42 degrees north. So we draw the limiting latitude, as you can see in the diagram, 42 degrees north. Now we draw an arc of great circle passing through A with its vertex at the limiting latitude. You can see with vertex at V1, the green part. Likewise, we draw another arc of great circle passing through B with vertex at the limiting latitude, and the vertex being V2.
Sir, इसका
Now the vessel shall
position
be moving along the.
Go ahead,
Sir, one
beta.
question.
Yeah, go ahead.
A and B का position sir opposite होना चाहिए ना sir? Northeast.
The B should be on towards the west because the D long.
Okay. Now, beta, A is at 141 east, B is at 122 west. Right, beta?
Yes,
So you are saying that position B should be west of A or on the left side of A, right?
हाँ sir.
Yes.
Okay. Now, beta, this doubt is coming. Yesterday, I told you to go into basic D-long calculations, right? How to calculate the D-long and D-lat. Right, beta? कल मैंने बोला था ना कि D-long calculation revise करनी है.
Yes, sir.
Yes sir.
So this doubt is coming because you have not revised the D-long calculations, beta. Okay. So you are basically crossing the international date line in this particular scenario and you are going eastwards. Okay. Let me show you here. I'll show you on the whiteboard. Give me a minute. I'm stopping the video for the moment.
Sir, in this question, as per D long is supposed to be 96 degree west.
Just a minute, beta. Right. Let me write the positions. One position is 141 east. So 141 east and the other position is 122 west. So we are going from 141 east to 122 west. Right? Okay. Now you are saying that we are moving in the westerly direction. Let us make the Greenwich meridian here. Greenwich meridian. Let's mark it as G. Easterly longitude 141 will be somewhere here. 141 east. And westerly longitude 122 is going to be somewhere here. 122 west. And you are saying that we are going in the westerly direction. So your logic is correct. We are going in the westerly direction like this. Now tell me what will be the D long between them, beta? A is here and B is here. What will be the D long between them? A is at 141 east.
180 degree minus 141 first from the
No.
A to
The
G.
D long here is going to be 141 plus 122. That is 3, 6 and 2. This is going to be the D long because from position A to Greenwich meridian, you have to move 141 degrees. And from Greenwich to 122 west, you have to move 122 degrees. So if you are going westerly, you are covering a D long of 263 degrees, beta.
263 west.
Now, it is 263 west. Our D long on the earth can never be greater than 180 degrees. That simply tells you that you are going in the wrong direction.
97 sir, that should be 97.
Exactly, beta. So ऐसे केस में जब ये D long 180 से बड़ा आता है तो आप इसे 360 से subtract करते हो. You subtract it from 360 That will give you a D long of 97 degrees. And when you subtract it from 360, the name changes to east. So what is the D long between them? It is 97 degrees east, 097 east. That is why you see B is on the right side of A.
Okay, sir.
Clear, beta?
Yes, sir, clear.
Very good.
Sir, just 180 degree minus 141 equal to what I getting, and also sir 180 degree minus 122 then equal to the same, the 97 is coming, sir.
हाँ बेटा, आप जो कर रहे हो वो बेसिकली क्या कर रहे हो आप अपने कान को ना
180
ऐसे
degree.
पकड़ रहे हो, है ना? ऐसे ही पकड़ लो बेटा सीधे.
Sir, we have one question, sir.
होल्ड ऑन,
If-
होल्ड ऑन, रुक जाओ. क्वेरी क्वेश्चन रुक जाओ बेटा. मुझे पहले ये बताओ कि जिनका ये डीलोंग का डाउट था वो क्लियर हुआ?
Yes, sir. Yes, sir.
अब एक लेसन है तुम लोगों के लिए कि जो काम होमवर्क दिया जाता है उसे कंप्लीट करना है बिफोर द नेक्स्ट क्लास.
Yes, sir.
क्योंकि अगर तुमने पिछला टॉपिक छोड़ दिया, मैंने कल 2-3 बार बोला था कि डीलोंग की कैलकुलेशन शुड बी क्लियर. सो अगर तुमने उसे छोड़ दिया तो नेक्स्ट क्लास में इट इज गोइंग टू जनरेट डाउट्स. सो होमवर्क इज टू बी डन बिफोर द नेक्स्ट क्लास. ओके?
Yes, sir. Before drawing, we need to know that.
That's right. I told you yesterday also that when you are making the triangle, if A and B positions are not correct with respect to each other, the answers will be wrong.
Okay, sir.
Okay. So go to PracNav book. In the second or third chapter, you will get these D-long calculations. Work them out. Very simple. It will not take more than 10 minutes, beta. But work them out. Get it clear in your mind. You will not have any doubts after that. Okay?
Yes, sir.
Okay, great. आप बताओ next doubt.
Sir, in group, there was a question regarding the great circle sailing. Question
Hold
number
on, beta.
4 of
Hold on. रुक जाओ. फर्स्ट हम वी विल कंप्लीट दिस. ये क्वेश्चन को कंप्लीट करते हैं. इसमें अगर कोई डाउट है तो मुझे बता दो आप. जो जीसी का डाउट है वो इसके बाद पिकअप करते हैं. अदरवाइज इट विल ब्रेक द कंटिन्यूटी.
copied, sir.
Okay?
Okay, sir.
Okay. So let me go back to the question. We will complete this and then come back to the doubt.
The track A to V1, which will be a great circle track, V1 to V2 along a rhumb line track, and V2 to B along a great circle track, completing our voyage from A to B. Now we draw the meridian of V1, angle at V1 is 90. We draw the meridian of V2, angle at V2 is 90. Now we mark off parts that we can calculate. Now PA, we all know, is colat of A, and value is 52 degrees 20 minutes. Then PV1 is the colat of V1. Now V1 and V2 both lie in the limiting latitude, so their latitude is 42 degrees north. Therefore PV1 is 48 degrees. Likewise, PV2 is also 48 degrees. Now PB would be the colat of B, and value is 53 degrees 12 minutes. The longitude of A and B give us this angle at the pole, which is the D long between A and B, and this value is 96 degrees 20 minutes. So now what we have done is we have marked the parts which are available to us, and using the two right angle triangles, now let us also identify what all are we going to calculate. We can calculate this angle. This will be D long between meridian of A and meridian of V1, and that can help us in finding the longitude of V1, whose latitude is already known. We can calculate these angles also. This angle will help us to calculate the longitude of V2, having known the longitude of B. Now this full angle is known to us, 96 degrees 20 minutes. So this angle can also be calculated. So all these three angles at P we will be able to calculate. We can also calculate angle A, and this shall help us in giving the initial course when the vessel sets sailing on this GC track at A. We can also calculate angle B, and this shall help us in getting the final course of the vessel. You can get this distance A to V1, distance V1 to V2, and distance V2 to B. All these added together shall give us the total voyage distance. So now we solve the two right angle triangles to find the missing parts. We first deal with triangle PV1A, and this triangle in the diagram is shaded for easy identification. It is this triangle we are talking about. We make the Napier's cartwheel with V1 being 90. And I'm sure as the cartwheel is being completed, you can also revise with it. So there the cartwheel gets completed. Now in the cartwheel, we identify the parts that are known to us. What we know is PA and PV, so they get identified in the cartwheel. Other three parts we can calculate using Napier's rule, so they come up with question marks. Now we can apply the Napier's rule. We can first apply for AV1. Sine of the middle part is equal to product of the cosines of the opposite. When we put the values, we get AV1 is equal to 24.045 degrees, which multiplied by 60 becomes 1442.7 nautical miles. That is the GC distance from A to V1, and this distance we transfer to the diagram here. Now we write the formula for angle P of the triangle. Sine of the middle part is equal to product of the tangent of the adjacents. We put the values and we get the value of P as 30 degrees, 58.8 minutes. It's transferred here. Now this is the D long between A and V1. So if the question wanted the coordinates of V1, then we could have found the longitude of V1 by applying this D long to the longitude of position A. However, since it's not required, so we are skipping it, and we write the formula again now, and obviously this time we want to calculate angle A. Sine of the middle part is equal to product of the cosines of the opposite. When we put these values, we get angle A as 69 degrees, 51.2 minutes. This value we transfer to the diagram here.
So beta, this is the solution of the first triangle, Papa Victor 1 Alpha, and we have obtained the three unknown items. Any doubt in this calculation, beta, up to here?
No, sir.
No, sir.
Very good, beta. Great.
Now we can solve the triangle PV2B to find the missing parts therein. The triangle is shaded, so this is the triangle in question. So we first make the cartwheel for right angled triangle, right angled at V2. So this is the cartwheel with V2 being 90 and other parts being filled in the cartwheel clockwise from V2. Now we identify the known parts. Known parts are PV2 and PV. So PV2 and PV are known to us. Other three can be calculated. So we have question mark out there. Now we apply Napier's rule. First we can calculate BV2. And when we put the values, we get BV2 as 26.462 degrees, which is 1587.7 nautical miles. And this distance we put up on the diagram here. So the distance on the GC track from V2 to B is 1587.7 nautical miles. Now we write down the formula for angle P of the triangle. So here is the formula, product of the tangent of the adjacents. Put the values. Angle P comes to 33 degrees, 58.9 minutes, and the value of the P goes into the diagram. Again, had the longitude of V2 been asked for, we could have applied this d long to the longitude of B to get the longitude of V2. Not required, so not being calculated. Now we write the formula for getting angle B in the triangle, product of the cosines of the opposite. And when we put the values, we get B is equal to 68 degrees, 08.3 minutes. The value comes out here in the diagram. So now we have calculated all the three parts of the triangle PV2B.
Clear, beta? The second triangle, Papa Victor 2 Bravo.
Clear, sir.
Very good, beta. Great.
So now, if you see in this diagram, there are only 2 question marks left. Rest of the unknowns have already been calculated and filled in. One is this angle. Now, since we know this angle, we know these 2 angles now, so this angle can be easily found. So now angle APB is 96 degrees 20 minutes. The other 2 angles are known to us, and this way we get angle V1PV2, that is this angle, as 31 degrees 22.3 minutes, and this value goes into the diagram. So now only missing part is this rhumb line distance. Now we know this 31 degrees 22.3 minutes is the D long between V1 and V2. Also, the vessel is doing rhumb line along 42 degrees north. So this distance shall be corresponding departure in this latitude. So by parallel sailing formula, we know this cos V1 V2 will be equal to D long into cos of limiting latitude 42 degrees. When we put the value, we get distance V1 V2 as 23 degrees 18.8 minutes, which is equal to 1398.8 nautical miles. So we get the distance V1 V2 using the formula cos lat is equal to departure upon D long. This distance goes into the diagram. Now everything in the diagram has been calculated, whatever was missing. So whatever was earlier known is shaded with green ticks. Whatever has been calculated is indicated by these yellow highlighted values in the diagram. Now let's come to summarizing of the answer now.
सर ये V1 V2 का
Composite
cosine
track
formula
is-
से भी हो जाएगा ना?
Okay.
2 sides and included angle मालूम है.
Okay. So the doubt is, can we calculate Victor 1, Victor 2 using cosine formula?
Yes, sir.
Okay.
Not
Tell me,
possible.
beta, is this
Not possible.
triangle Papa Victor 1, Victor 2, is this a spherical triangle?
Cannot do it, sir. Cannot do it.
Yeah, that's correct. You cannot do it because this triangle Papa Victor 1, Victor 2 is not a spherical triangle, beta.
Not a spherical triangle. Okay.
The side Victor 1, Victor 2 is a small circle. It is not a
Small
great
circle,
circle.
not the great circle. Yes, understood.
Right. So you cannot use cosine formula for Victor 1, Victor 2, or Napier rule you cannot apply.
Yes.
Okay.
Thank you.
Sir, angle P, sir, how you get an angle P, sir?
Okay.
Victor 1, Victor 2, sir.
Okay,
Angle
beta.
P.
Okay. Look carefully. Angle alpha Papa Bravo was known to us. It was 9620. It is the D long between A and B, right?
Yes.
Angle alpha Papa Victor 1 was calculated in the first triangle. This is 3058.8. And angle
Yes, sir.
Bravo Papa Victor 2 was calculated in the third triangle, 3358.9. So these two smaller angles were subtracted from 9620 to get the middle angle P, Victor 1 Papa Victor 2, which was 3122.3.
Yes, I got it, sir.
Right, beta?
Yes.
It is mentioned here on
Yes,
top
sir.
on the left hand side. So this is how we got it.
Sir.
Okay.
Distance from A to B shall be sum total of these 3 distances.
Go ahead, beta.
सर ये पैरेलल शेलिंग के कौन से फॉर्मूलाज हैं सर? एक तो ये डी लॉन्ग इनटू कॉसलेट है.
यही एक फॉर्मूला है बेटा, नो अदर फॉर्मूला. यहाँ पे यही
मीन लैट
फॉर्मूला यूज
एमलैट कुछ बोला था सर बीच में
ओके ओके
पहले
whether you call it cos of latitude or cos of hemlat, it is one and the same thing because both these positions are on the same latitude beta. When you are on a parallel track, you move along the same latitude.
yes sir okay yeah only one formula for parallel sailing
Only one formula, departure is equal to d long into cos of mean lat.
right
Sir, okay, sir. Sir, now we have calculated the distance A to B. There
Right.
are one exam questions they are asking calculate great circle distance and calculate rumb line distance and find the difference. So
Right.
in that if I'm calculating for rumb line A to B, so I can use the parallel sailing formula, right?
No,
Because-
beta, no. The parallel sailing formula can only be used if alpha and bravo are exactly at the same latitude. If their latitude is different, then
Okay.
you will not be able to use parallel sailing. You will have to use Mercator sailing then.
Okay, sir. Mercator sailing. Okay.
Yes. I will cover up Mercator sailing also with you. The next class we'll cover up.
Okay, sir. Okay.
Okay. So let's close this out.
And you can see that comes to 4429.2 nautical miles. The second requirement of the question was the initial course. So let's go to the diagram and mark out, place a vessel as she would be heading at A. Now, as explained in the earlier videos, let's mark off the initial course clockwise from true north at A. This arrow represents the true initial course. Now we can see clearly that angle A that we calculated is directly equal to the initial course. So therefore, initial course is equal to angle A expressed in three-figure notation 069 degrees 51.2 minutes true. Now to get the final course, let's place the vessel as it would be as it reaches B. The vessel would be as this. Now clockwise from true north at B up to the ship's head, let's mark up the final course. This represents the final course here. Angle B calculated is this one, and we can see final course will be 180 minus angle B, and that's how we can get a final course, that is 180 minus angle B. The final course is 111 degrees 51.7 minutes true, and this way we get all that was asked from us to be solved in this particular question.
Okay, beta. So this is the question as well as the solution. Now, any doubts anywhere, beta, in the solution of composite sailing problem?
No doubt, sir. For
Very
now.
good, beta. Great.
Sir.
Very good. Go ahead.
Sir, understood everything, sir. Just one doubt here, sir. In this slide, you written the parallel sailing, sir. What is this cos V1, V2, sir? It's actually
Okay.
only V1, V2 is the departure.
Yeah,
Departure, no,
good
sir?
you notice that. This cos is basically a typo error. It should be V1, V2 is equal to D long into cos of latitude. V1, V2 is the departure. So this
Yes,
cos
sir.
is a typo error here. Just delete this cos.
Okay, okay, sir. Understood.
Okay, beta. Great. Clear? Shall we close this out?
yes sir
Yes, sir.
Very good, beta. Closing down. Okay. So, beta, now you can go into composite sailing questions. Praknav ki book mein, after the Great Circle chapter, you will see the composite sailing chapter. So you can go to the composite sailing chapter and you can practice one or two questions there. One or two questions you practice. If you get their answers and confident in the solution, that would suffice. No need to do all the questions in the exercise. I will be sending you one assignment. Okay. Now the questions which you have done from Praknav book are basic level questions, base level questions to give you confidence. Exam questions are slightly of the higher level. So I'll be sending you one assignment. It'll have some questions which are basically the exam level questions. And I'll send you the solution also with that. So practice those questions better. Okay. If you get stuck anywhere, you can take help from the solution. Don't copy the solution in the beginning. Try to solve it yourself. If you get stuck, then only look at the solution, take help and proceed ahead. Right?
Yes, sir.
Okay, great. So मेरी जो assignment है, that's little tricky and complicated. Shall I send it today or tomorrow? I believe
Today,
today
sir.
you can.
Today.
Shall I send it today?
Today, sir. Yes, sir.
Sir,
Oh.
is this the same assignment you send in phasing classes?
Yeah, more or less same, beta. Maybe
9
there
and
may
10,
be
9 or
little
10
bit of.
questions, sir.
These are amended. The maybe same, maybe little bit of corrections there
Okay.
or
Okay,
additions.
sir. Okay, sir.
Sir, I have one query regarding I stuck in one question, sir. Can I share, sir,
Yeah.
with you?
Please go ahead now, beta.
Sir, in question that comes in the MMD examination, their initial course, final course is given. Also, we got the D long, angle P, and then they are give to find out your final position. Then, in this condition, which formula is going to use, sir? This cannot be
Okay.
solved by the Napier.
Very good. I got your problem. They have basically given you the three angles of the spherical triangle.
Yes, sir.
Papa, Alpha, Bravo, three angles are given. So basically
Yes.
your doubt is what is to be done where three angles are given. Okay. इन केसेस में बेटा एक नया कॉन्सेप्ट यूज होता है, दैट इज द कॉन्सेप्ट ऑफ पोलर ट्रायंगल्स which we will be covering in the next class.
Sir, we try out bipolar, sir, but the problem is to find out the exact value of initial and final course.
No problem. Let me cover up this polar. After that, if you have any problem, tell me.
Okay.
Sir, the issue is that
Go ahead. What is the issue?
degrees true like that. But when we were solving great circle problems, we were finding out the values of angle A and angle B, and then we were converting it from quadrantal to true course. But via the diagram, we were seeing that where it is in which quadrant. Likewise, in these questions, when the true bearings are given for initial and final course, I'm facing difficulty in getting the angle A and angle B from that true course.
Okay, all right. You follow that 1, 2, 3 method in reverse, beta?
I tried, sir, but I'm facing difficulty in that.
Okay, अभी कर देते हैं. Let me take you to the whiteboard. You just give me the courses. Whatever is
Yes,
given in
sir.
the question, just give me
I
the
have-
courses. Hold on. I'll take you to the whiteboard.
I have posted that question in the group, sir.
No problem. Just read it out, beta.
Sir, initial course was 319.
Just a minute. Just 1 minute. 1 minute. 1 minute. Let me open up the whiteboard.
Yes,
1
sir.
minute. Let's erase it. Okay. Tell me, beta, what are the courses given?
The initial course was 319 degree, 22.8.
Repeat once again.
Initial course 319 degree,
Okay,
22.
319 degrees. Let's leave the minutes for simplicity. This is the initial course. What is the final course?
Final course 298.
290.
298, sir.
298, sir.
298. Okay, very good. This is the final course.
And D long is
D long 33 degree, 49 minutes.
Okay, D long is 33 degrees. Any
Yes, sir.
indication about which hemisphere, beta? North or south?
northern hemisphere.
North hemisphere. Very good. Great, beta. Now you see, beta, course 319 is a northwesterly course.
Yes, sir.
319 would be something like this. This is 319. And 298 is
Also northwest.
also a northwesterly course. Right?
Yes,
So
sir.
basically the track is something like this.
Yes, sir.
Yes, sir.
Agree, beta?
Yes, sir.
So let's mark the pole. Since it is the north hemisphere, we mark the north pole. Let's mark the initial position meridian. So at A, the ship is here, like this. This is on a course of 319.
Yes, sir.
and then we reach somewhere here. This is B, and at B the ship is again like this. This course is 298,
Sure.
right beta?
Yes.
अब बेटा 319 जो कोर्स है, starting from north, going clockwise, going up to the ship's head, this is 319.
Yes, sir.
360.
So can you tell me what will be angle A beta?
360 minus 319.
Very good.
40
41 degrees. आ गया बेटा angle A?
Yes, sir.
Very good. Let's go to the next course. Next course is 298. Starting from north, going clockwise, going up to here is 298. 298.
Minus 180.
Now beta, you tell me that from the stern of the ship up to the bow of the ship, this angle
Is
is
180.
going to be 180. Very good. So if this red angle is 180, what will be the inner angle? Let's make it green.
180 plus that angle B.
Very good. 298 minus 180. So this is going to be
119.
118 degrees or whatever.
Yes.
Understood, sir.
Okay. These are the two angles of the triangle beta. So आगे angles?
Yes, sir. I have come to this. From here, I cannot proceed further.
Yeah, 290, no? 360
Well,
minus.
hold on. इसके बाद इसे कैसे सॉल्व करना है? Now this third angle is 33 degrees. Angles हमने निकाल लिए. This much we had covered earlier. इसके बाद इसे कैसे सॉल्व करना है वो मैं आपको नेक्स्ट क्लास में कराऊंगा. It will be solved
Okay, sir.
using polar triangles.
Okay, sir. Thank you so much, sir.
Okay, beta. All right. So closing this down now. Great, beta. Very good. So composite sailing covered. Please practice a couple of simple questions before jumping into the assignment, beta. क्योंकि assignment में directly jump करोगे, you may lose morale. Okay. So practice a simple question. चाहे तो यही वाला practice कर लेना जो अभी हमने देखा था. So just practice this one question. Be comfortable. Then you can jump into the assignment. Okay.
Yes, sir.
Copy that, sir.
Little bit extra will be there, like it will have some concepts of Mercator sailing. Okay, so whatever doubts come in, that we will cover in the next class. 90% of it is covered. Okay, all right. Great, beta. So that's all from my side for today. Anything you want to ask or share? Great, very good. So we
sir,
call off
tomorrow's lecture also. Sorry. Tomorrow's lecture
Tomorrow-
also will be working on GCA. Same thing.
Tomorrow you have a chart work class, beta. Our lecture is, I believe, day after tomorrow as per the schedule.
Okay.
So, sir,
Okay.
for next class, what topic you will cover, sir?
In the next class, Tuesday,
Yes, sir.
Tuesday we will cover polar triangle and one more tricky concept. Okay. So these are the two concepts which are remaining in GC and composite questions. इनको cover करेंगे. Any doubts you have in the assignment, that we will cover up. And after that, I will take you to the basics of other sailings. दो sailing हमने अभी की हैं, GC and composite. I will take you to plain sailing and Mercator sailing, the concept of meridional parts, वो सब cover करेंगे.
Okay, sir.
Okay.
Okay, great, beta. See you then. Bye bye. See you in the next class.
When will you cover all these thing on Tuesday?
या बेटा on Tuesday.
Okay.
Okay. मैंने sequence बता दिया है. इसमें से
Sure,
कितना
sir.
cover हो पाएगा, that will depend upon the speed with which we move.
Yes,
The
sir.
doubts,
Right.
how many doubts you will have. So
Right,
let us
sir.
see how much we can cover.
Yes, sir. Sir, apart from topic, can I say one thing, if you don't mind?
Go ahead.
Sir, do you know Ankur Wariku?
Yeah, I watch his videos.
Sir, has somebody told you that you two are very relevant in appearance?
Yeah, many people told me, but
Yes, sir.
many people told me. So
Yes, sir.
in fact, my wife also keeps telling me that you look like him.
Yes, sir. Uncle Variku. Okay, sir.
Okay.
Thank you, sir.
Great, beta. See you then. Bye bye. Bye bye.
Bye, sir.
Bye, sir. Bye, sir.